Good morning students, welcome to tutorial class for the subject physics. Today we are going to discuss chapter 10 and the chapter 10 includes light and it has two parts. One is your reflection, another one is your refraction. Now before starting the chapter, let me discuss this question, and the question is like this: what makes things visible? So as per the statement, let me read out: an object reflects light that falls on it. This reflected light, when received by our eyes, enables us to see things. Now if you want to see an object, what are the things you need? The first thing basically you need is your source. You are not supposed to see an object if the surrounding is dark. So to see an object, what do you need first? You need a source. The source may be a bulb, maybe a candle. Now what this source do basically? This source emits light, or yes, definitely the source emits light, and pictorially basically we used to show by arrow. So source emits light and that light falls on the object. Now a part of the incident light gets reflected from the object, and that reflected light, when falls on our eye, then you can see the object. If the object absorbs all the rays that comes from the source, then definitely we are not supposed to see the object. For object to be visualized, definitely the object must have to reflect a part of the incident light, and that light must have to enter on our eye, then you can see the object. So this is very simple. I think most of you know. Now before going to the actual topic, reflection or refraction, let me go for the two properties of light. Now I think in your class we have done this experiment, and the experiment is like this. You do have a source. The source may be the candle flame, or maybe a bulb, and in front of the source you have to place two cardboard. Now as per the diagram, this is your source and this is one cardboard, this is another cardboard. Now on this cardboard we have make a pinhole, and also in this cardboard we have made a pinhole. Now we can see the light from this side if these two pinhole are in a line, but we are not supposed to see light if somehow we displace this cardboard, and displacing this cardboard means these two pinhole does not in line. So this experiment shows that light travels in a straight line. So this is one important point, that light travels in a straight line. Now this statement has limitation, and this limitation can be explained by this diagram. Now this is your source and this is your convex lens. I think most of you know, if we place the source at the focus of this convex lens, the refracted light must be parallel, is not it? So after passing through the convex lens, the parallel rays will comes out. Now these parallel rays passes through these two obstacles. This is one obstacle and this is another obstacle. Now these parallel rays again strike on this convex lens. Now on the focus of this convex lens we have placed a screen. So as these rays are parallel, so definitely after converging by the convex lens, it strikes on this screen. Now what we try to explain from this experiment. Now you see here we have shown that light travels in a straight line, but if you try to visualize this setup, you will see that the light enters in the shadow region also. but the obstacle is here, no? So if light travels in a straight line, definitely there will be no illumination on this shadow region, and definitely there is no illumination in this shadow region. But practically, if you perform this experiment, you will see that some illumination occur in this shadow region also. So what does it mean? That definitely some bending occurs, and this bending of light is known as diffraction. Okay, this bending of light is known as diffraction, and the property exhibits from this experiment is nothing but the wave nature of light. So first experiment shows that light travels in a straight line, but the second experiment shows that light does not travel in a straight line, rather it travels as a wave, and this gives the origination of the wave theory of light. So we have written here light travels as a wave. That's why some illumination occurs in this shadow region. Okay, more we'll discuss, or more you will get in higher class. Now let you go through the note part. Note part explain that wave theory of light often becomes inadequate for treatment of the interaction of light with matter. So definitely all the theory has limitation. So wave theory also has this limitation. It does not explain the interaction of light with matter. So this wave theory further modified, and later on it comes that light often behaves somewhat like stream of particles, and that particles are nothing but photon. Okay, so more we will get this thing in higher class, and this gives the origination of Einstein theory of photoelectric effect. So this thing you will get later on in higher class when you are in class 11 or when you are in class 12. And if you are interested, you go through this part, Einstein theory or Einstein equation of photoelectric effect, or Einstein theory of photoelectric effect. So more you will get that light seems to be a stream of particles, and that particles are known as photon. Okay, these are the discussion, may not be from your exam point of view, but you must have to know. Now the topic which is from exam point of view is a reflection of light. Now all of you know what is reflection. Bouncing back of light into the same medium is known as reflection of light. Okay, so here we have given a ray diagram. You see there is an incident ray, and this is your reflecting surface. So ray strike on this reflecting surface, and after that it reflects, and at the point of incidence we have drawn a normal to the reflecting surface, which is nothing but the plane mirror. So laws of reflection, I think most of you know. The angle of incidence, the angle made by the incident ray with the normal is known as angle of incidence, and the angle made by the reflected ray with the normal is known as angle of reflection. So first law, the angle of incidence is equal to the angle of reflection, and the second law is the incident ray, the normal to the mirror at the point of incidence, and the reflected ray all lie in the same plane. Now next topic which we are going to discuss is your properties of the image formed by a plane mirror. I think you have got this one in lower class. First property is your image is virtual and erect. Erect means straight. It means if you stand in front of the plane mirror, the image should be erect. Erect means if your head is up, it seems to be up in the image, and if your head is in down, it should be in down in the image. So this is your erect. So virtual part is your what? You are not supposed to focus the image on the screen. That is your virtual. And size of the image is equal to the size of the object. So what is the size of the object in front of the mirror? Same size you will get in the image. And the third point is your image formed is as far behind the mirror as the object is in front of it. So image distance is equal to the object distance, and definitely image is laterally inverted. It means if your left hand is in front of the plane mirror, it seems to be the right. Okay, that is your laterally inverted. Okay, now more will get this thing later on, and probably you have got this thing in lower class. Now the next topic which you are going to discuss is your spherical mirror. So as the name suggests that the mirror is a part of a sphere. So what we have written, mirrors whose reflecting surface are spherical are called spherical mirror. And there are two types of spherical mirror. One is your concave, another one is your convex. Now concave part, basically inner surface is your reflecting and the outer surface is your non-reflecting. And what we have written, a spherical mirror whose reflecting surface is curved inwards, that is faces towards the center of the sphere. This is your reflecting surface, and that dash part is your non-reflecting surface. It's called a concave mirror. And convex mirror, a spherical mirror whose reflecting surface is curved outward. So this is outward part is your reflecting surface and inward part is your non-reflecting surface. That is your convex mirror. A spherical mirror whose reflecting surface is curved outwards is called a convex mirror. So this is all about today's discussion. Please go through. I think some topic you know and some topic seems to be new. Please go through this topic and find out your doubts, and you can ask anything related with this topic whenever you need. Thank you.